All right, guys, welcome to 3.3 Extra Practice. We are on page 114 in your textbook, and I'm just randomly going to pull a couple of examples just to help you along if you're having some trouble. And this little portion of this video is designed to give you some extra practice if you're having trouble, just for a little more extra help, especially for those of you who can't make it in, whether it's in the morning or after school. So the directions are always going to be tell whether the two ratios form a proportion. I'm not sure if we've defined the word proportion completely, so just a quick review. Proportion means taking the two ratios and are they equal to each other. So tell whether the two ratios, the two fractions, form a proportion simply means form equal fractions. Okay, so here's example number 1. 1/3 and 7/21. So we want to figure out if the two will be equal to each other. So we take 1/3 and we take 7/21. The easiest way I find to answer every single one of these questions is to take the cross product. Take 3 times 7, and that gives me a solution of 21. And then I take the cross product in the other direction, 21 times 1, and I get a solution of 21. So 21 equals 21, so they are equal. Another way, and I'm sure some of you are sitting there a little confused, we could reduce the fractions. 1/3, 7/21. Since you have a calculator, you can use the N/D button, and you can punch in there 7/21. And you will see if we divide by 7, if you don't have one of the calculators from class, we get 1/3. So this would reduce to 1/3, and 1/3 does equal 1/3. A third way we can do the same exact problem is by taking 1/3 times the numerator and denominator by 7/7, and we get 7/21. And if you notice, these two ratios are equal to one another. Okay, so hopefully you're finding that to be helpful. All right, another example we can try is, let's get rid of that. It's 2/5 compared to 40/16. So we're going to take our two fractions and we're going to determine if they're equal to one another. I always start with the cross product. If you like reducing, go ahead and reduce. But for this problem, I'm actually going to do absolutely nothing, and I'll show you why. This example here, it's what we call a proper fraction, and I can't reduce it anymore. But if I take a look at this next example here, right in here, 40/16 is what we call improper. Okay? And I know I can reduce it, so if you use the N/D button, 40/16, it reduces to 5/2. Okay? Is 5/2 the same thing as 2/5? And hopefully you're saying no. So when I have a proper fraction and an improper fraction, I know immediately that they're not going to be equal. So equal sign with a line going through it means not equal. If you hate that explanation, here's another one. We had 40/16. We're just going to do this problem the way I've been showing you the others. We can take the cross product. 16 times 2 is 32. And take the cross product the other way around. 5 times 40 is 200. So if you take a look, 32 and 200 are definitely not the same. So the answer would be the equal sign with a line going through it for not equals. And I'm just going to do one more example for you because I'm sure you've spent just enough time on the computer already. We're going to take a look at 4/15. We're going to compare that to 15/5. over 42. Again, the easiest way is to just take the cross product. So 4 over 15 compared to 15 over 42. So we're going to do 42 times 4, and I get an answer of 168. And then I'm going to do 15 times 15, and I get an answer of 225. If you notice, 168 and 225 are not the same, so we use an equal sign with a line going through it to show not equal. All right, we're not comparing them, we're just trying to figure out if they form a proportion. Are the fractions equal to each other, is what this question is saying. Okay, well, thanks for your time, and I'll catch you next time.